So what we learned so far is that when in physics, when we want to describe motion, we can measure, the distance traveled over time. And something that we see is something maybe like this. This is the distance. I'm going to say distance is x, and this here is time. And for every second, I see one increase, right, on the distance traveled. If I start at a point like x0 here, and this is, let's say, is xf, okay? But every second, I see the same change. So how can I record that? I could say that v, that is the velocity, the average, v is going to be delta x over delta t. And this is this slope of this line, okay? The slope of this line is the rate of change in terms of the distance traveled, okay? If the rate of change is constant, that means that the velocity is constant, okay? If I say I travel 60 miles per hour, in 2 hours, I'm going to travel 120 miles. So I know I traveled 120 miles, okay? So I can describe my motion. We'll also talk about vectors that, we need to give the direction in where we're going, so we can define where we're going to be after 2 hours or so. So from here, we come with this formula that is x final plus vt, right? It's delta t, I plug in here t. So this is the average. Also, the average can be calculated based on v final plus v0 divided by 2, okay? Now, if the velocity is changing, in every second is changing, so we are not going to have a straight line here anymore, right? If the velocity is increasing, can you tell me how the graph is going to look like if the velocity is increasing, if I have x over t? A parabola, right? So let's say it's something like this. Now, what if the velocity is decreasing?
The other way. The other way.
The other way, right? It's going to be something like this. Right? Okay? Okay, so in order to calculate the acceleration, the average acceleration, right? The average acceleration, we're going to have delta v over delta t. And from here we get another equation, now is vf, v0 plus at. Okay? Now, I want to come to this equation here. I want to come to the equation of vf squared equals v0 squared plus 2ax. Okay? How do I get that equation? Where's that equation come from? Okay? So, so I want to eliminate the time from that, right? I want to eliminate the time. So one way is to use this formula here. I'm going to say like delta t is going to be x f minus x0 divided by the average, VA. That's one formula that I can use here, okay? The other formula that I can use from here. Delta t is going to be VF minus V0 divided by A. So I have these two formulas here. I can call this here delta X. Let me erase this. Okay? Just from here, right? From here. Delta T, delta X over delta VA. But delta VA, what is delta VA? Delta VA from here, I can plug that in here, right? So let me, from here, I'm going to come here, I'm going to write down now that delta T is going to be delta X divided by VF plus V0 divided by 2. And delta T is also equal to this, okay? So when I do that, I'm going to have here VF minus V0 divided by 2. So I have now this formula, and I want to come up with this one. This is the acceleration. Okay? So I can cross multiply this. Those are two fractions here. I can cross multiply, right? This times this is going to be equal to this times that. Do you guys understand that? That I can do this? Cross multiplication rule. Do you know why we have this rule? Cross multiplication rule. If we have two fractions, they are equivalent. For instance, let's say 2 over 3 is equal to 4 over 6. These fractions are equivalent, right? Do you agree with me? That 2 over 3 is the same as 4 over 6, right? Cross multiplication rule says that the product between 3 and 4 is going to be the same as 2 and 6. Okay? So 3 times 4 is 12, 2 times 6 is 12. So I can do that. So that's why I'm going to do the same here. Okay? So when I do this, I'm going to have here, I'm going to multiply this first. So it's going to VF minus V0 times VF plus V0 divided by 2 A delta X. Okay? So now I'm going to have VF minus V0 times VF plus V0 equals 2A delta X. Now, what is this here equal to? Does anybody know? Binomial products?
Oh, it's V squared minus VF squared minus V whole squared.
Exactly. So this is VF squared minus V0 squared equals 2A delta X. So that's the formula that was missing that we didn't cover last class. Okay? So, and the other equation that we had was the XF equals X0 plus 2VD plus 1 over 2 A D squared, right? That is another formula that we had done last time. So now we have covered all equations of motion. We can describe, you know, any object, right? That is being, where the acceleration is constant, okay? So this equation here, if we analyze this equation, now you have to, you know, look at the equations and try to understand. If there is no acceleration, what's going to happen? Well, if there is no acceleration, this term is going to disappear. Then we have this here. That is the same as this one here. Remember that here the acceleration was 0, right? Velocity here is constant. If I'm going to graph this, what is the graph of this? It's going to be for velocity is going to be a straight line, right? Horizontal line, right? Now, when we have this situation here, the distance is a parabola, right? What will be the graph for the velocity here? That is going to be a straight line going up, and acceleration is going to be a constant, right? And you can see that here also, right? If acceleration is zero, now interpretation of the equation, right? If the acceleration is zero, what happens? Well, final velocity is going to be equal to initial velocity, right? Velocity is constant. So everything here is mentioned. But there is one thing that we didn't cover yet up to this point, right? We did last class. We start talking about what is that cause, you know, an object to start moving, right, from rest. What is that cause an object to being accelerated?
Force.
What is behind? Force, right? So, and we saw that with Newton's first law, right? What is Newton's first law? Go ahead, go ahead.
An object at rest will stay at rest, and an object with constant velocity would stay at that until another force pushes it away.
Yeah,
Stops it.
it requires an external force to be applied to it, right? So that is Newton's first law. And, you know, I hope you all understand that. It was a very difficult concept to get, right? I remember it took me 1 year to learn that, okay? Then the second one is, what is the second one?
The greater the mass of the object is, the more force is required to move it.
Yeah. So, can you talk about the second
Wait,
one? Yeah.
I don't remember. Wait. We did it last class.
Yeah. To move a truck, you're gonna need to apply more force than to move a little car. And if you move a truck, it's gonna be slower than if you do the same force in a car because it's lighter, so it's gonna be faster.
Very good. So what that means? That means that force is proportional to acceleration, okay? So this is what you should think. Newton's second law, it states that the force is proportional to the acceleration. Acceleration is a vector, force is a vector, right? Applying a force in one direction, acceleration is going in that same direction, okay? Now, this proportional constant, we call that the mass, okay? And that is related with the first law. If you think they all related, right? More mass, more resistance, right? More resistance to start moving, right? More mass, more resistance. So that is second law. Is that clear? What about third law?
Reaction has an equal and opposite reaction.
The action and reaction, right? So those are the three laws. Okay. So today we're going to learn another force. It's called a friction force, right? Because you know, what is the difficulty to demonstrate Newton's first law? That a body is in motion, it maintains, it's going to continue to be in motion. What is the difficulty there in creating an object that is going to be moving continuously? Is there a difficulty? You guys did the experiment last time, right? And you were trying to show, first part, the cart, that glider was floating on the air track, and you did a little push, and what happened to it? You measured the time, that flag went through the first photo gate, and you measure the time on the second photo gate, what did you observe? Was the
It was
time
the
the same? The same, right? And would that be possible if the air was not there, that, you know?
No.
No, right? If you give a push on the glider, what would happen? It would stop, right? So what is happening there? There is what? If it's stopping, it's because there is a
Deceleration.
force, right? There is a force there. We call that force friction, okay? So today we're going to study that, and this friction, what are the parameters that you think are going to affect friction?
The weight.
I want you to take a minute now and write down a piece of paper all the parameters you think, and that is a productive favor, okay? Question, right? So save that, write down right now, everyone, okay? All the parameters that you think are going to affect the friction. Like that experiment you did last time, right? The glider was floating on the track because of the air, and I had no contact with the track, and you give a push, and the thing just glided through it, right? No force being applied to it, nothing, it just moved on. So now, we're considering two surfaces, right? Like this block. Today we're going to do experiment with this block on an incline, and I want you to think about what are the different parameters that are going to affect, you know, the friction. It's going to increase the friction or reduce, so what are those parameters? Do you think maybe the area? Do you think that the material is important? The angle of the track? There are all those things that you'll be able to change. The weight, okay, so I'm going to erase this. All right, so let's talk about, I have a block on the table, and the block is not moving. The block is at rest, okay? So we do have, the block has certain mass, so we have the weight, okay? So the weight is mg, right? So the mass, and this is the weight. The weight is a force, okay? It's a force. It's mass times acceleration. Mass is just mass. So if I have a force, just one force, then this block should be moving, right? The force is down, so the block should be moving down, but it's not. So there is something holding it. So in order to hold the sum of all forces, in this case, in the y direction, has to be 0. Then I'm going to have a normal force. It's a reaction force, right, from the table that's holding it, preventing from going through it, right? So that's what a normal force is. It's a force preventing you to go through it, contact force, okay? Now, the second situation here, and if I were to draw the free body diagram, right? Free body diagram. This is mg, and this is n, right? I hope you guys read this section on the book about free body diagram. You know what the free body diagram is, right? So if you didn't do that, make a note, learning how to do a free body diagram, okay? Your book has that. So now, let's say this thing is moving. It's moving now at constant speed. If it's moving at constant speed, okay, what is going to be the free body diagram?
What
Let's say now the block is moving to the right at a constant speed. And I'm asking you, please draw the free body diagram. The free body diagram describes the forces on the body.
The vector that goes
To the right
to the right.
There is a vector to the right.
and going to the left.
The free body diagram describes the forces being applied to the block.
Okay, so there is a force that goes to the right.
There is a force that is going to the right. The force, the velocity is constant.
There is two vectors.
Huh?
There is two vectors. One of the friction this way and one of the force the other way. Is it friction less or no?
Well, this is Newton's first law, right? The thing is moving. The experiment you did last time, right? The cart was moving from photogate 1 to photogate 2 and spent the same time on both of them. So you
There was no
measure-
force because
Huh?
there was no force because
There was no
friction.
force,
No
right?
friction.
So what forces are being on somebody that, on a, body that is moving at
That
constant
would-
speed?
So that would be
So there
this
is-
vector to the left.
No, there is no vector at all. If it's frictionless, there is no vector.
Well, because even though you're still pushing it now, because we're pushing the car, so there's a little bit of force.
That's the
applied.
impulse, the first push.
That's
But
the
then-
first push. yeah.
And then after, if it's constant, there is no more force. It just limits life. But if it's on the surface,
But that means it's a,
then there is friction, so there is a force the other way.
Because it has contact, right?
If it has contact, so you have to have some kind of force that push it to make it like
To
you-
maintain it, right?
Like when you if you're on your car you have to apply acceleration all the time, like constant acceleration, to be in the same speed. Otherwise, if you leave the acceleration, then your car is going to stop because of the friction.
So let's draw the free body diagram now. So what are the forces on the block?
Well, one
Up
force,
and down.
one acceleration one way and one friction the other way.
So let's say I have
One
force
force.
F this way,
And then
and then friction here. I'm gonna put it here because this is a contact force, right? It's contact. What else?
up and
That's
down.
it?
and then I mean also
Okay.
the normal force and the weight.
So I would say the sum of all forces
Goes
on
zero.
the x-axis need to be 0,
Yeah.
right? So that means F plus F of F is equal to 0. And then the sum of all forces in the y-axis needs to be zero.
So N plus mg.
So, N plus mg is also equal to zero. All right? Is this flowing well with no friction in your minds? So you guys are, picking this up correctly? Following me? Or no? Now it's the time to talk a little bit. So Pamela, what do you think is kind of hazy? Is this looks logic to you, make sense or no? Based on everything that we learned so far, right? You have to keep in mind Newton's first law,
Yeah.
Newton's second law, and third law in order to understand this.
I would say, like, if you didn't know Newton's first law, it would probably not make a lot of sense, right?
Mhm.
But since you know, like, that every object that's at rest, when it's gonna stay at rest unless you put a force to it.
Right.
So, like, if you didn't know that, it probably wouldn't make sense that there's a force going the opposite direction.
Mhm.
But knowing that there's a force, it makes sense.
So this situation here, can you imagine that the block here could be at rest, right? If everything balances out, it could be at rest, but could
Still
also
be.
be at constant speed, right? Because everything is in balance, so there is no reason to have anything moving. Yeah.
Wait, so you said that this is the equation for that block to be at rest or at constant acceleration?
Yeah,
Or-
this situation here, I can see the object could be at rest or could be at constant speed, right? Because everything is in balance. This here is equal to that, right?
So to make it move one way, to make it move to the right, the force moving to the right needs to be greater than the one moving to the left.
No, this is already moving, right? Yeah, I gave a first impulse and the thing is moving.
If I want to move faster,
So it moves
Yeah, if I
faster.
want to increase, the now velocity is not constant anymore. So let's do that drawing here now. Let's do that, okay? Now, I'm going to do that here. Is that okay? The block. Now, the block is moving with F, but F is greater than F of F, okay? Now F is greater than F of F. So that means, for sure, it's not at rest here anymore, right? It's not at rest, right? So I still have here my friction, F of F, friction, okay? And then I have also the normal force, and then the weight, mg, right? Now, because of this, when I write, let's write the F of y. Is this equal to 0?
Yes.
yeah.
Is equal to 0. So this is going to be the same, n plus mg. Now let's do the sum of f of x. What is this equal to?
2.
0?
No.
No, it's not 0. Look, f is greater than f of
Do
f.
F greater than F of F.
So I can write that, what?
It's just,
F is greater than
it's
F of
F plus F of F, still. Just because F of F is negative, so
So f,
plus F of F.
well, but they are opposite sides, right? This is going to be negative of f of f, and this is going to be equal
But
to what?
the F of F is already negative.
is
So it's-
negative. I'm putting the sign now, right?
Because right now you're putting like negative, negative. F of F is negative.
Yeah, but I'm putting the sign now, I'm putting the absolute value here, just to
Oh,
make
yeah,
it
yeah.
clear, otherwise you're gonna be confused, right? Because F minus the magnitude of this force is gonna be equal to what?
The acceleration
Acceleration, just A, here like this,
times the mass.
times the mass, right? Because this is the sum of all forces, right? Okay? So now we have this story here. Now let's start thinking about on an incline. I have now my mass, okay? And so here, what is the free body diagram here for this one? The free body diagram. What is a free body diagram? We replace the block by a dot, okay? And then we put all the forces that are there. So you have here mg, you have here n, you have here f, and we have here f of x. And you see they go different ways, so they have opposite signs, all right? So now I'm gonna do this here. I have here angle. The angle is delta, right? And I want now put my forces here. Let's say at first there is no friction, okay? No friction. No friction here. No friction. So, what do you guys think?
Go down.
It's going down, but I'm not asking, it is going down, right? But can you put down the forces there?
I can.
You can?
Can I do it?
You wanna come here and do it? Go ahead.
So
So that means that f of f is equal to 0.
It's gonna be 0?
so is F. No, it's not F. There's this one. There is mg. There is this one. There is n. And then that's it.
That's
And
it? Yeah.
That's it.
That's it.
And that comes down because of sine theta, right?
Very good. Excellent. So what is the free body diagram here? It's gonna be, I'm gonna put here the dot, and then I have mg here, okay?
So, assuming that we're talking about here on Earth, right? Wouldn't n force be upward? Wouldn't it have to be like a straight line instead of diagonal? Does
Well,
gravity come?
Yeah, it's kind of a strange
Gravity
way.
is always going to be like that.
Yeah, because
But the normal force has to be perpendicular to the surface.
Yeah, you wanna make
no,
it
because
known?
I was saying because regardless, okay, I was gonna say that n should because gravity affects goes this way, right?
Yeah.
So gravity is still affecting the block on a vertical line.
Yes.
So shouldn't
That's the mg.
n
That's the mg.
oh yeah. Okay.
You talk about
yeah,
the
yeah,
normal
yeah.
force?
Yeah, I was talking about okay, never mind.
Okay, very good.
Yeah.
Thanks.
So what is is it sine or cosine?
Well, now, I know it's kind of, awkward position, right? Here, it's kind of easy to think about it, right? What is the coordinate system here? The coordinate system here is like this, right? I have here x and I have y. X is parallel to the plane, right? The plane here is what? Is horizontal, correct? The plane is horizontal. X is parallel to the plane. But here, my plane has an angle to it. do you have any suggestion how to make math a little easier for me? Otherwise, if I have my coordinate system the same way I had before, like here, right? I bring my coordinate system here and I put it here like this. It's going to be kind of difficult to describe those two vectors there. What would be a better way to look at this? I can make this here like this,
Yeah, just-
parallel to the incline.
X, like that, yeah.
Yeah, I just make my X this way and my Y that way. You guys allow me to do that, or it's gonna be easier, right? So, when I have that, if I extend this a little bit, what is this angle here? Can anybody tell me what is this angle?
The data, you say no?
Look, I have a triangle like this. This angle here is theta, right? Here is what? 90, right? We
Nine minus
know
eight.
the sum of angles,
So it is data. The other one is data.
right? If this is perpendicular like that, right?
Right.
Perpendicular means here is 90, right? So this angle here,
Is,
90 minus-
90 minus data.
this one angle here is 90
Minus
Minus.
data,
minus theta, right?
yeah,
But this whole thing here is 90, so this one here has to be
data.
10, okay? So this is very important because students always get confused with that. So this here is theta, okay? This angle is the same as this one, okay? So, now remember, mg is a vector, n is a vector, and now I want to describe the sum of forces on the y-axis, right? So how am I going to do that? Well, is the block moving in the y direction, back and forth? Is it moving?
What is it?
Is the block moving in this direction?
No.
No, right? So the sum of all forces needs to be equal to 0, right? So that means n minus mg what?
Equal to 0.
Huh?
Equal to 0.
But it's the projection here, right? This force here is the projection, right? Projection. What is the projections of mg on the y-axis? This is projected here. What is that projection?
Oh, theta. The angle?
The angle, so I put angle here, like this.
No, it's sine data.
Sine, the projection here is sine.
Close.
If I have this here, this here is sine.
Oh, wait. No, it is, yeah, it is. What? So,
Cosine.
yeah, no, opposite.
Cosine.
Cosine.
Yeah.
Cosine.
Yeah, it's, I just,
Cosine, right?
I always get people confused.
Yeah, you need to have the trigonometric circle
I know it's
in your mind. So this is theta, right?
Yeah.
What is the sine? What is the cosine? Well, the cosine is this projection here, right? What is the sine? This one here. So if I'm projecting this here, this is the angle, so it's going to be cosine. So this force here that is balancing out the normal force is mg cosine theta. Is that clear? Now let's analyze this. So what is that we have from here? Here we have that the normal force is equal to mg cosine theta, right? Let's look at the situation where theta is 0. If theta is 0, what are you going to see? N is going to be equal to what?
1 mg.
Mg.
Yeah.
Is this equal to this one? For this situation here, right?
Yeah.
N is equal to mg. You guys see that? Right?
Yeah.
Now, if the angle this here is 90, what's going to happen? What is the normal force if the theta is
0.
90? Huh?
0.
0. Normal force is 0. Right? If I put a block here, let's see this block. I'm going to put the block here. So if I let it go, what do you think is going to happen? Falls, right? It goes straight down. Okay? Free fall. Right? Straight down. So this is okay. So now let's move on to the next situation where now we have friction, right? Oh, no. I still need to continue here. Okay. Let's do now the sum of all forces on the x-axis. What do you think is going to happen?
That's what gets me confused. That the y-axis as cosine, it should be sine. And the x-axis as sine, it should be cosine.
So
And
now,
I know I made it in my head.
so now is the projection there, right?
Yeah. And that's sine. Yeah, that's mg sine theta.
So it's going to be mg sine theta, right? Mg sine theta. Now, if I let the mass go from rest, right? What do you think is going to happen? Can you imagine what's going to happen? If I let this block free go down this track with no friction, what is happening here? From rest is going to accelerate, right? So accelerate means there is a force. The force is m what? M times acceleration, right? M times acceleration. Okay? So this mg sine theta is equal to ma. Now m and m on both sides of this equation. So acceleration is equal to g sine theta. Now look at this formula and describe to me what happens as I increase the incline.
You increase the speed.
Huh?
You increase the speed.
Increase the speed. What
The-
about?
The acceleration, sorry.
Increase the acceleration, right? As I increase it, when sine is 0, what is the acceleration?
G.
Huh? When sine is 0, the acceleration is
0.
0. So I have a block, and this here is the incline. I put the block here. Where's the acceleration? 0. If I put the block on an incline, it's going to accelerate. Okay? If there is no friction. Right? If there is no friction. So this is the equation. Acceleration, does the acceleration depends on the mass?
Yes. Wait.
Acceleration depends on the mass?
No.
Do you see mass here?
No.
No. The acceleration depends on the area of contact?
No.
No. Okay? It's here.
If there is no friction.
Now let's talk about friction. Okay? Let's talk about friction. So I'm going to erase this because I don't have space anymore. So I'm going to erase this part here. So this is the free body diagram for this situation. So if I have now, just gonna put it out here like this, same angle theta, and now here I have my block, and now I have friction. So, what are the forces here?
MG, come down,
Again, mg,
normal force.
normal force,
And friction.
and friction here, right? And friction here. Okay? So, can you tell me the situation that the block is not moving? Or the block is always gonna move? What do you guys think? Is the block always going to move? Here we saw that, the block will always move here, right? We're gonna have, actually we have acceleration. Now, here, what's gonna happen? Can you describe what's gonna happen?
Wouldn't the friction continuously slow it down until it just stops depending on the type of friction that's there?
Well, it depends on the,
Well, because I've seen like say we're like on a mountain, the slope, I've seen things go down mountain, but completely stop at like halfway and still incline. You get me? So like that
so
just
it depends on like the, I don't remember how you call that, but like the degree of friction. If it's like if it's very soft, then it's gonna keep going down. If it's very like if the degree of friction is higher, then it's gonna stop eventually. So it depends on the material of the surface, of each surface actually, the object and the,
Yeah, both surfaces, right? It's going to depend on
and the
both
area.
Yeah. Do you think the area is gonna affect?
I don't know. That's my predictive favor, I guess. Answer.
Would you have to apply the rate of change of,
So, if I put the block here, tell me what's gonna happen. The different situations
gonna-
that might happen here.
like unlike the other one, which is gonna have pretty much continuous acceleration until it reaches final end, that one is not gonna have a continuous acceleration. It's gonna decelerate as it goes down the slope.
Okay. So, let's put here again, the free body diagram. How does the free body diagram looks like in this situation? You have here mg. See, free body diagram, you only think on the forces being applied to the object. Okay? So we have the weight, we have the normal force going this way, and we have the friction going this way. Okay? So now, let's write down the equations, okay? Again, I can extend this, and I can extend this, and I'm gonna have here, this is theta, and I'm gonna have the projection of the weight on the y-axis, because now I have my coordinate system this way, right? Conveniently adjusted, so I make my life easier here to describe this. And then let's start with the sum of forces on the y-axis, okay? Here again, I have what? That n minus mg, what?
Cosine.
Cosine theta is going to be equal to 0. So that's my first equation. Is this okay?
Yeah, it's the same, yeah.
Albert, are you following me on this? Is it okay, Antonio? Now, let's analyze the other situation, right? So, I put the block there. Do you guys think it's going to slide or it's going to be there? Not moving.
It will move,
It will move.
yeah.
Anyways, it will move anyways, right? Do you guys agree with me? So,
Like, I mean, depends if, it depends on the friction.
Depends on the friction, but they said it's gonna move. You think, if it depends on the friction, what do you think is gonna happen? It's not gonna move.
I mean, it depends on, yeah, I don't know, how much friction is applied to this.
Well, yeah, I guess if the friction is greater
Well,
than the.
If the friction is
If F of
greater
F
than
greater
the,
than F,
The
Then
thought,
the-
the
Yeah.
thought that's going through my head anyway.
then
is
G sine,
if you
if
put
the
it-
friction is greater than G sine, then it's gonna stay.
Right, but like, I don't know, I feel like it's still gonna move like a slight amount before the friction would just completely stop it, you know? That's how I'm seeing it, but I
Well,
honestly don't know.
if,
I get
if,
what you're saying, that, if F of F is greater than F, then it's not gonna move.
If I take this and that, and like, if I take that, okay, then there's inclination. And even,
Yeah.
well,
So that's what, yeah, that's where the friction.
if I take this, because the surface is the same, but this is different, because this has like those like little things. So,
Okay, so it looks like, from what I hear, is that it might not move, right?
but we don't
So
know,
let-
so
yeah,
we try.
Yeah, might not move, or it might move. It might move accelerated, or it's gonna be at constant speed.
But again, it depends. If the friction is equal, the object is already moving. Yeah, so it's either it moves or it's either it stops or it's big.
So it looks like, do you guys think that, you know, if I have, I'm doing this experiment, let's assume, let's imagine now, right? I'm doing this, I have the block here on the horizontal, right? And I start increasing the angle here. The block is sitting there, it's not moving, right? Not moving. But then as I increase my plane here, my track, right? Then it starts moving. Right?
Yeah, because
The friction
sine,
computer.
the value of sine theta increases.
Increases.
So
It comes
the
to a
G,
point that-
the value of G, like instead of like being less than 9.8, it gets closer to 9.8, and then
So let's try to do that situation that, you know, is not moving, is at rest. Okay? Let's see if that's possible. So it's clear that the Y, they're not moving in that direction,
Yeah.
right? Is going to be equal, right, here. Now, if it's moving, if it's not moving, so we need to have some sort of balance. So the sum of all x's is going to be mg, what?
sine
Sine
theta.
theta minus f of x. And if it's not moving, this here has to be equal to
0.
0. Okay? Now, the friction force is a contact force, right? It depends on the normal force, right? It depends how close you are to the surface, right? The contact between this surface. So it has to be proportional to the normal force. This proportion, remember the proportion for between force and acceleration, we call mass, right? That's a constant. So there is a constant here that is going to depend on the surface, and that is called μ, and that is the coefficient of friction. That depends on different surfaces, okay? So friction force proportion to the normal force by this constant that is which called coefficient of friction. And today on the lab, we're gonna do, you know, different surfaces, and we're gonna measure this coefficient. All right? So in this case here, I can plug this in here, right? And I have a system of equations here. N is equal to N is equal to mg cosine theta, right? From here, from this first equation here, I get that. From here, I'm gonna get that F is me N, so I'm gonna have here mg sine theta equal to coefficient friction N, that's mg cosine theta, okay? All right? Now, this I can cancel. I can cancel this, I can cancel this, okay? Are you guys following me? So what is the coefficient of friction? Coefficient of friction is sine theta divided by cosine theta. This is the same as tan, the tangent of theta, okay? So the coefficient of friction depends on what? On the angle, right? Does it depend on mass
No.
here? No, the formula is not showing, it depends on mass. Does it depend on the area?
No.
No. Coefficient of friction depends on the angle, right? So, so this is the situation where the block is not moving. Okay? Now what do you think? Do you think the friction is the same if the block is at rest, or is it moving? What do you guys think? It's going to be the same?
Say that again.
Is the same value?
Do what?
Can you repeat the question?
The question is, do you think the coefficient of friction is the same when the block is at rest versus it's moving?
Yeah.
Yes.
Yes?
Yeah.
Because the angle is still the same.
So,
Because it's actual regardless of the angle. The coefficient of friction is the coefficient of friction, that's it. So the end is always going to be perpendicular to the surface, so it doesn't matter of the angle.
Because the only thing that affects the coefficient of friction will be the angle. So if you increase the angle, then the coefficient will change. But if you maintain the coefficient,
wait, but this formula is for the situation where it is not moving, right? This is imbalance, right? Now, when this thing is being accelerated, right, or is moving, the situation is going to be different. So can I erase this here, right? I'm going to erase this here now. I'm just going to leave, I'm going to copy this formula here. A equal G sine theta, okay? I'm going to copy this formula here. But now, here, I'm going to write down the same system of equations here on the situation that we have here actually an acceleration, okay? You guys want to do that? Okay, so let's do that. So here's the same, you know, the sum of f of y is going to be n minus mg cosine theta is equal to 0. Now here, the equation is going to be different. Of fx is going to be mg sine theta minus f of x equal to what?
coefficient.
Acceleration.
A? Like that?
MA, in like
M-A.
mass,
Yeah, M-A. Okay, excellent. So now it's different, right? So I can replace this guy here again, okay? Because f of f is me normal force. So I'm going to do the same thing here. So I'm going to write down mg sine theta is going to be minus b, and then the normal is going to be mg cosine theta, and this is equal to m8. How's that? Is that okay? So it's no big deal, right? It's the same equation, right? I have the same equation here, right? It's just that now you have to think about it. The thing is not moving, right? Zero. There's no acceleration. Okay? Not moving. No acceleration. So I solved this and I got this. Now I have here some acceleration. So this has to be equal to ma. So when I solve this now, I'm going to solve this for the coefficient of friction, right? So when I solve that, I'm going to first eliminate m, cancel m, right? So I'm going to have here g sine theta minus me g cosine theta equals 8. All right? So if I move this around, I'm going to have g sine theta minus a is equal to me g cosine theta. So when I calculate for the coefficient of friction here, I'm going to have g sine theta minus a divided by g cosine theta. So now the coefficient of friction, you see, is not going to be the same as this one here, right? So if I further do here some calculations, I can now divide this here. This part is going to be tangent of theta minus a g cosine theta. So I have an extra term here, right? I divided this term by g cosine theta, is tangent of theta, and I divide this term by this. So this coefficient of friction, when the thing is moving down, being accelerated, is it going to be greater or less than this one here?
Less.
It's going to be less. So I'm going to call this here, because it's not moving, the coefficient of friction is static, because it's not moving, right? This here is moving, and I'm going to call this one here the coefficient of friction, the kinetic coefficient of friction, okay? The coefficient of friction when it is moving. And when it's moving, I just showed you here that it's going to be what? Greater or less? Less by this amount here, okay? Is this okay? All right, let's go to the lab and work on those experiments.